Hello, cosmic explorers! Welcome back to Infinite Horizons, where we chase the universe's biggest secrets with curiosity as our fuel. I'm your host, Miko. If our last episode left your mind spinning with multiverse possibilities, you're in for an even wilder ride today. We're calling this episode Echoes from the Edge. Right now, the James Webb Space Telescope is shattering records, showing us galaxies from the absolute dawn of time. Meanwhile, groundbreaking data on dark energy is hinting that the fabric of our reality might be more dynamic and perhaps more interconnected than we ever dared to imagine. So settle in, maybe dim the lights, and let's dive into the freshest science from the frontier. This is the news rewriting the story of everything. Let's start with the star of the show, the James Webb Space Telescope. As of early 2026, JWST has fundamentally restructured our timeline of the early universe. The big headline? The confirmation of a galaxy called MOM Z14. Scientists have spectroscopically confirmed it at a redshift of 14.44. To put that in perspective, we are seeing this galaxy as it was only 280 million years after the Big Bang. What's truly shocking is its brightness. It's far more efficient at clearing the primordial fog of hydrogen than any of our models predicted. It seems the early universe was a lot more crowded and active than we thought. And it wasn't just lonely galaxies out there. JWST recently captured something called Webb's Quintet, a massive merger of 5 galaxies occurring just 800 million years after the Big Bang. This chaotic smash-up was already enriching the surrounding space with heavy elements a billion years earlier than expected. Even more surprising, JWST detected complex building blocks like metallic iron and silicon carbide in the dwarf galaxy Sextans A. This proves that the ingredients for planets can form even in environments with very low metal content. It seems the universe was planet-ready almost from the beginning. While JWST looks at the light, another instrument is looking at the dark. The Dark Energy Spectroscopic Instrument, or DESI, has released its latest findings, and they are sending shockwaves through the physics community. For decades, we treated dark energy as a cosmological constant, a static force pushing the universe apart. But DESI's 3D map of over 15 million cosmic targets suggests otherwise. The data now favors a time-varying dark energy model. Essentially, the force that expands our universe appears to be weakening over cosmic time. This deviation from our standard model reached a 4.2 sigma statistical significance late last year. In science speak, that's incredibly close to the gold standard of a formal discovery. If dark energy is changing, the cosmological constant is dead, and a new era of dynamic physics has begun. This ties directly into the invisible scaffolding of our universe. In January, researchers released an ultra-high-resolution dark matter map using data from the Cosmos Web Survey. It captures the filamentary web of the universe with twice the clarity we had with Hubble, showing exactly how dark matter guides the visible world. Now, if a weakening dark energy sounds like a headache for old-school physicists, it's a dream come true for string theorists. This weakening aligns perfectly with what are called swampland conjectures. These theories suggest that a stable, constant vacuum is mathematically impossible. Instead, they favor quintessence models, where dark energy is a dynamic field. But it gets even weirder. Early 2026 research is leaning into the it from qubit theory. This suggests that space-time itself isn't a fundamental thing, but an emergent property of quantum error correction. This would mean the multiverse isn't a collection of separate bubbles, but an interconnected web of entanglement. Under the ER equals EPR conjecture, distant regions of the cosmos, and perhaps other universes, are linked through a massive web of quantum wormholes. Before we wrap up, we have to look at the here and now in our own neighborhood. On July 2nd of last year, we detected a record-breaking 7-hour gamma ray burst, known as GRB 250702b. It turns out we watched a black hole slowly devour a star in a rare tidal disruption event. And for those of you with a telescope or just a clear view of the morning sky, keep your eyes peeled for Comet Pan-STARRS. It's reaching its closest point to the sun on April 19th. It's currently visible to the naked eye, glowing at a magnitude of +3. It's a rare chance to see pristine material from the Oort cloud, the very edge of our solar system, passing right by our front door. The findings of 2026 are showing us a universe that is far more dynamic, chaotic, and interconnected than we ever imagined. From the record-breaking light of MOM Z14 to the weakening pulse of dark energy, we are moving toward a view of the cosmos where everything, from the smallest quantum bit to the largest galaxy, is part of a single, tangled web. It reminds us that the edge of the universe isn't just a place in space, it's a frontier of knowledge that we are expanding every single day. That's it for this episode of Infinite Horizons. I'm Miko. If today's journey into the quantum web sparked your curiosity, subscribe and share this episode with a fellow traveler. Until next time, keep looking up. The echoes from the edge are calling.